the grasp on you got the grasp on LACP, you got the grasp on PAGP, you got the grasp on what I call the static one, you know, where you just turning it on. It's not sending LACP or PAGP packets. But what you were digging recently was in reference to how does it select a given link to send traffic from one host to the next. And that's when, let me see. I'm sitting here looking at my switches here. And of course, you know, you got the load balancing, which gives you a few different options, such as MAC addresses, source
Claude,
IP. Yeah.
You should be able to share your screen if you need to.
Okay. Let me see here. Let me see what screen I'm gonna do. Screen number 1. Yeah. Okay. So you see my green on green putty?
Yeah, you can see it.
Okay. All right. So we got for example, I got this here one ether channel that's up and running on mine's port channel 45. Okay. Now, the thing is, and Dave, we can probably experiment on yours for a much cleaner picture. And the reason why I say this is because I actually have mine's my internet's running through mine's. So you see those packets are
shit. Okay.
So they're constantly incrementing. So for us to actually see the selection happening per link, I probably should have had it set up where the internet's not running through them.
That's all good. Let me I'll start booting it up now. My bad.
Okay. But yeah, but to get back to what we were talking about. So like in this example here, you see my ether channel summary. And I'm gonna highlight this here P045, this port channel 45, which consists of fast ether links 45, 46, 47, and 48. Okay. And the signifier P, you know, if you look into the legend up here, you'll see that it's bundled in the port channel. So them 4 links is what make up my port channel 45. Now, when you're looking at, let me see, show ether channel load balance. All right, so when you're looking at the possibilities, the different methods of load balancing across the ether channel, you see right now mine's is set on source MAC address. Okay, but let's say if we wanted to change that, let me see, ether. Our interface.
And I guess I'm not sure if you got a drawing of your home topology, but with the source map, what is it doing? You know, how is the links being selected now? Of course with the source map, but how is it doing that calculation from a switch standpoint?
So what happens is it goes through this Boolean algebra. Okay. And at some point, you know, most of us are tech, we all tech here. We all learned about probably AND gates.
Boolean.
Yeah. So it's doing an exclusive OR based on the bits of the address. So just for quick calculation, and I saw earlier when you was talking about you were doing yours, but it seemed like it was coming out the same ports.
Yeah, when I had it set to source and destination IP.
All right, so check this out. So this here is a calculator that y'all all are familiar with, right?
Mm-hmm.
And I got it set on programmer so that it can actually show the binary version of a base 10 number that I put into it. Okay.
Mm-hmm.
So I think for example, the addresses that you were using on one side, you had a .150.
Yep.
Okay. Now you can see the binaries equivalent to that down here.
Mm,
So you
got you.
see the last 2 bits, right?
Right.
We got a 10. And I
Mm-hmm.
think the other IP address that you was using was 50.
50.
Yeah.
Yep.
So we look at that and we got the same exact thing.
Okay.
Okay. A 10. So what happens is in an exclusive OR situation, if you got 2 alikes, then it's going to give you the opposite. So an example, if you get, let's say if we just do the XOR calculation on this last bit 0. So you got a 0 for the 50 and you got a 0 for the 150. So
Right.
those 2 zeros are going to give you a, let me see, likes gives you the 0 and unlikes give you the 1.
Okay.
Yeah.
And the one being, I guess, and I'll look back at my notes. The 0 being a certain link, or the 1 being a certain link. Is that
No,
how?
so let's take a look at this. Let's take a look at this. All right. So
Okay.
if you have 4 links in an ether channel, right?
Right.
You got to say to yourself, in binary, how many bits does it take to express 4 different options?
Mm-hmm.
So what you do is you say, okay, I can use 2 bits to express 4 different options. And when you
Mm-hmm.
think about it, you're talking about links 0 through 3. So I can go 0, 0 binary. I can go 0, 1 binary. I can go 1, 0 binary, or I can go 1, 1. You follow that? You follow what I just did? So I just basically went
Right.
from
Yeah.
0
Yeah.
to 3, which represents 4 different links
Within
expressed
the
in,
with the 4-link ether channel.
right.
Ah. Okay.
And,
Okay.
and, and
Okay.
is it
Gotcha.
is it because you did 1 through 3 in the last 2 bits?
Yeah. Yeah. Yep.
That makes
So
sense.
so
Okay.
that's the thing. So basically to express 4 different possibilities, you need 2 bits. And
Mm-hmm.
that's basically that number 1 slot and that number 2 slot.
Got you. So okay, that just made sense to me. So, and just based on the article that I found,
Mm-hmm.
and just reading your article this weekend, and stuff like that. Now that makes sense to me. So it makes sense now. So if it's a 4-link bundle, all right, we need 2 digits so we can have 4 values for all 4 links.
Yeah.
So if I have 2 links in a bundle, then I could just use 1 bit.
Yeah. Yeah.
Wow. Okay, so wait a minute. So let's say if I have a 6-link bundle, then I'll just need 3 bits.
Right.
Okay. That makes fucking sense. Wow. This is perfect. Okay, cool. And again, the only reason why I asked is Ken, I know when you said in your article, it does it in the background, but
Mm-hmm.
that's not enough for me. I want to
yeah.
see what it actually does and see. You know how I am.
Yeah.
I just want to do it on paper and see. Oh, yeah, it's going to choose this link. It's going to choose that link, et
Right.
cetera, et cetera.
Right.
So,
Yeah. At your
okay.
IE levels, you definitely got to be able to know why it's selecting that. Definitely.
Yeah. Okay.
Yeah. Because I think when
Wow.
I wrote that article, I didn't even have my CC at the time. I had my CCENT. I was just, again, can't nobody stop you from reading whatever you want to read, no matter what certification
Not at
you
all.
got.
Not at all.
But yeah,
Not
so
at
that's
all.
where your link 0, your link 1, link 2, link 3 comes into place at.
Got you. Okay.
So
Okay.
where both of these bits were the same for the .50 and the .150 address.
Mm-hmm.
So you had bits that were just alike, which meant if you did the expression on it, your output is going to be 0, 0, which is basically your very first link in the bundle. If you think about it, you know, so you take the last 2 bits that you see on my screen for this here 50. Okay. And so what you see is if you do the bit by bit, the 0, and then you do the bit by bit, the 1 versus 1, you both come up, come up with 0, 0. And that's probably going to be your first link in your bundle. Whatever bundles you had, that was probably going to be your first link, and that was all it was going to use for those two numbers. So then I saw another one that you had was you used an address of 200
and 100.
Okay, 200. You see the bit here?
It's 0. Yeah.
Looking at 0, 0. And then you use the other one, you said IP of 100.
100.
Same thing.
Yeah.
So this would have been the same scenario as last time.
Okay. If I'm using
those IP, the IP method.
The IP. Okay.
Yeah.
Got it. Okay.
So with the IP method, I see how it's like 150, but it's going to be 0, 0 because it's always looking at the last 2 bits only exclusively.
Yeah. So let me bring up Paint real quick.
And Claude, I just or Claude, if you want to pull up the shit, did I take a screenshot of the lab? Hold on. Hopefully that can make it easier. Hold on. Give me a second.
You want to put it in Slack?
Yeah, let me take a screenshot for you.
Okay, because what I'll do is I'll take it off of there and put it on Paint and draw on it.
Yeah, I was kind of imagining it.
There you go, Claude.
Okay. All right, let me see here.
That makes sense. Oh my Jesus. Wow, that makes sense. Jesus. Appreciate it, man.
Man, no problem.
That makes sense. Man, that makes, because you know, you can read an article and it's like, all right, cool, all right. Yeah, this is good stuff. We're using big words, we're using complex words, we're gonna confuse whoever's reading it. But again, that's why I like your article. Your article is just like, cool, we're gonna get to the point, then we're gonna go ahead and move low level and get to the actual, you know, point. Of course, you know, luckily I took courses and I understood what the XOR means just because I would do Boolean stuff for like Python and Java and HTML and stuff like that.
Right.
But yeah, it's like reading that CC expert article. It's a good article. It was just, you just made everything come together within his article. So yeah.
All right, so we looked at that calculator and we saw that 100, let's just take the last 4 bits. Right. And we're going to go 0, 1, 0, 0, right?
Right.
So we'll go XXX, X dot space 0, 1, 0, 0. And then the 200. We get basically, we got 1,000, right? So let's just write, let's write 2,000. Let's write the 1,000 up in there. So 200 equals to 1, 2, 3, 4, 1,000. Yeah. So what happens is we are going to do this individually with that first set of zeros, right? And then we'll do it again with the second set of zeros. And that's basically what it's comparing. Okay. So exclusive OR. Okay.
If we're using, and this is using the source IP method.
Yeah. But it's going to be an exclusive OR function no matter what the method is.
No matter what. Okay, gotcha.
Yeah. So we know that if we have a 0, plus a 0 and a 1 plus a 1, they're going to be likes. Then what's going to happen is we're going to have the output is going to be equal to a 0. All right. On the flip side, if we have unlikes, so if we have a 0 plus a 1, or this vice versa, 1 plus a 0, output on an exclusive OR is going to equal to 1.
Right.
Okay. So when you did the 0, 0, 0, 0, 0, 0, your link of these here 4 Etherchannel links here.
Mm-hmm.
Hold on a second. I got a sneeze that's just tickling me. But
no, go ahead. No, do what you gotta do.
So you got you got the exclusive OR. So you got zeros matching on zeros on both these links, which in essence is going to give you an output that looks like
Okay.
0, 0.
Right.
Okay. Now you have the choice. Like I said, we expressed this in 4 different possibilities.
Right.
0, 1, 1, 0, or
and then 1, 1.
1, 1. Link 1,
Right.
link 2, link 3, link 4.
Hold on. Okay. No, I'm thinking that's a future question I probably got to ask you, just about odd number of links. But go ahead. My bad. I'm jumping too ahead.
Okay. But yeah, so that's why all your traffic for those IP scenarios that you gave, because I was looking at when you sent it earlier, you sent me that snapshot in Slack earlier today, and then you said, yeah, all my stuff seemed like it's going through gig 01. Am I missing something? I was like, no, you ain't missing nothing. You got it. You got it. You just thinking you want some activity on 2, 3, or either gig 10. But
Exactly.
based on the IPs that you threw in there, because our brains like working with them nice even numbers.
Exactly.
You know. Now, let's say if you would have threw an IP address in there of, let me see that last one you used like a 150. Let me see if you use like a 153. 153. Okay, now you got now you got a number 1 on that last bit. That's going to change some shit.
Exactly.
Yeah, that's going to change some stuff.
Exactly.
You see what I'm saying?
Okay. Yeah, that makes sense.
So now you might get a link number 1 being used right here. You know,
if I'm using the IP method.
Yeah.
As my load balancing algorithm. Okay. Got you. But if I'm using my MAC, if I'm using the MAC address, no matter if it's a source or a destination MAC, then it's gonna change every time.
Yeah, it will. It will.
Okay.
Because then what you got to do is, let's go to a hexadecimal scenario, and let's say you got a MAC address of
55.
Okay,
Call
55.
it.
All right. So here's your last bits, 0, 1. Okay. Or you got a MAC address of, let me clear this, C8 Alpha Bravo, 78 Alpha Bravo. So here you got your last bits, 1, 1. You see? Same 4 links still. You follow me? But you're just going to focus on these last 2 right here. That's 1, 1. And then it's still, again, it's going to fall on, one of these in this
numbers.
output. Yeah.
Oh, okay.
It's going to fall in one of those.
Wow. Okay. And see, and Claude, I know you're modest, man, but dude, everybody else I tried to watch all weekend, just on YouTube and in the past 2 weeks about it. I've been at Etherchannel for the past 2 weeks, just hitting my head up against the wall. But it's this is in its simplest form, and it's like you kept it mad simple, and the point just got across. Like I get it now. Like everybody else was like, oh, it does the XOR low order bits. I'm like, bro, why we using all these big words? Bro? Why we why we doing all this, bro? Why
Now I know you are a Wireshark fanatic, but if you don't want to use Wireshark, you can actually use
the debug.
Not necessarily the debug, but you can actually use this command right here. So if you know the links, know the links that you're using, you can do a show interface, that interface number, pipe it,
and see if it's
packets,
increasing or not.
Yeah, packets output input, packets
right.
output actually, packets output because you're going across the wire, and you know, clear your counters first.
Gotcha.
Yeah, clear your counters, so that way everything can start from 0, 0. Let me see if I had it. So that way
Claude,
everything.
I'll get Eve ready.
Okay. That way everything will look like this. You know, you clear your counters, everything looks like 0, 0, 0, 0, 0, 0, 0. So that way when you start sending your packet bursts across in increments of, let's say, you know, 20, 40, 50, 100 packets at a time, you go back and you check these individual links, and you know, you use your up arrow to get to those commands real quickly, and you'll see where those 200 packets went across individually.
That is amazing. Jesus Christ. Yeah, that makes sense. Wow. Okay.
And like I said, I didn't mine's isn't a good, because right now my internet's going through my stuff. So
no, I got you. I'm gonna go ahead and I'm booting it up now. So if you just give me like a few minutes.
Yeah, we good.
And, boot stuff up. But dude, that makes sense of the XOR like calculation that's happened. Like now I can do it on paper now. Now it feels good. Now I feel comfortable.
So you can expect what you should see.
Exactly.
You can expect, and you know, here's the funny thing. With my live gear, my 3750s, let's say if I calculate it right, and I send a ping from, let me see, you got a PC number 6 up here, and let's say I send it over here to PC number 4 down here in the bottom corner. I can look at my actual 3750s, and I will see that one link in that bundle going crazy.
Blinking like crazy.
Yeah,
that's the selected link. If I'm using the algorithm of IP.
Yeah.
Okay. Got you. Okay. Got it. Let me go ahead and boot this thing up. Claude, you want me to switch back the algorithm
go ahead.
to IP?
No, you go ahead. Go ahead and keep it the way you got. That way we can
keep it. Okay.
Yeah.
Gotcha.
And then, you know, you can see that. Then you can go back and change your IP address on one of the other ones and see how that behaves. You know.
Okay. Gotcha. You want me to give it even numbers on one side, odd numbers on one side as far as the IP?
Well, you had evens before. Start off with that. Start off with that.
Right,
yeah, matter of fact, you can set it back up the way you had it earlier today.
Got you. Okay.
Somebody had a question in here?
Yeah, so I know how Etherchannels work, but I've never took it as far as XOR, but I understand it now that you explained it very simply. So I was just asking, I had a question about failover. Is it like an automatic thing when, like, so let's say gig 01 gets yanked out. Is it like it goes automatically to the next one? Do you have to set a command?
So what'll happen is, if for some reason gig 01 goes down in the bundle, then what'll happen is the exclusive OR will recalculate things based on 3 available links.
An
exclusive OR is just an algorithm?
Yeah, that's all.
Just a Boolean, bro. It's just
that's
a Boolean.
All.
That's
it.
Just a if or if else, whatever.
Yeah.
So, oh yeah, that's cool.
Yeah, in your early days of technology, you probably learned about AND gates, OR gates, inverters, yeah, stuff like that. That's basically what the exclusive OR is all about. It's in that logic family. And see, you know, I'm familiar with it because before I got into networking, I was all about electronics. I used to deal with a lot of op amps, you know. And
Gotcha.
that's where where I got my education from as far as understanding logic gates. Now, later on, Dave, you and I will probably get into the whole situation of, let's say if we had this ether channel maxed out, and anybody on
Okay.
the call, if you can tell me how many ports can be bundled in an ether channel.
8. Yeah.
Okay.
8 links and well, my bad. 16.
Yeah.
8 will be active.
Exactly. There you go.
Yeah.
So
Yeah.
here's the thing.
Hey, wait, can you say that again?
So the amount of links that can be bundled into one ether channel. So here he has 4 in his diagram, right?
Right.
And actually, am I still sharing, or did Dave take over?
I took over.
Okay. Yeah, so you see he has 4 individual links that make up his ether channel. The question was, what is the maximum amount of links that can be bundled in a given ether channel? And that's where the 16 came from. But only 8 will be active.
So you can put 16 as far as like backing them up.
Yeah.
Is that the point of that?
Yeah.
Yeah.
Yeah. So if you have within your 16 link bundle, if you have one link that fails, and we can, I think I could push it up to 16 links. But if you have one link that fails, it's automatically going to activate the next link that's in order within your bundle, within your 16 link bundle.
In production, how many would typically be bundled for that, just in case scenario?
In most
I mean,
production environments, it can, I don't see it going no more than 3 or 4 in a production environment, especially with these fast links they got nowadays.
What I've seen within a
Okay.
campus environment, within just a campus environment, yes, I only seen like Claude said, 4 max is like 6, but like data center, oh yeah, 16, no question. 16, no question.
Now here's the thing. Like he said, if one link drops out, another link comes into play, right?
Mhm.
Now, Dave, this is something you and I probably get into later on when you start getting into your CCIE stuff real deep.
Yeah.
There is, and it's something you probably haven't looked at in your books yet, but there is a specific mode that determines which switch will make that decision on which link is going to jump in as the replacement.
Mhm.
And that's what's known as the LACP master switch, which is different than the bridge ID. Because when I came across it, I had to wrap my head around it, because I'm thinking, okay, bridge ID is, the root bridge is the end all be all of decision making, right?
Mhm.
That's not the case when it comes to ether channels and making that selection of who's going to be the next link to take over if one fails.
Mhm.
So you got ports that's in a bundle, and then so you got 8 ports that's in a bundle. As a matter of fact, let me see if I can find this real quick on my Facebook page. I know I got it here. I'm gonna post it up in Slack.
And Claude, I'm gonna set it back to the default.
Okay.
Just so I just want to with your explanation that you just did, just
Yeah.
to go through the entire thing to see how how the calculation works, and then set it to like I had it before, destination map, to see the difference.
Yeah, matter of fact, I'm gonna put this picture up in Slack so everybody can see.
Nah, this is good stuff, man. Dude, you broke it down to its simplest form. Jesus. That worked. Man, yeah, I gotta watch this video again while I'm at the gym.
All right, the growth in networking Slack. That picture is loading and is loaded and should be dropping in there right now.
Okay.
There you go.
I'll share it in a second. Hold on. Okay.
All right, so you see all the way down at the bottom and that middle 30, yeah, that's 16 ports. You can see the green ones that's active and the brown ones, the amber ones that's just waiting.
Okay.
And like I said, the thing is, those 8 will do what they're supposed to do until one goes dead, one has some kind of hang up or something, and then one of those 2 switches that has the LACP master function will determine which link will go next in replacement. And I know I got snapshots of that as well on mine.
Is that where you set like the priority on the? I know what you're talking about, bro. It's like you set the.
Yeah. So each one. So here's the thing. There is a port priority that people think about when it comes to spanning tree. Then there's also a LACP
exactly.
priority.
That's what I'm thinking about.
Yeah.
Got you. Okay.
Existing priority or something like that. It's
yep.
Now, Claude, my question to you:
Yeah.
Can you set that, or is that statically set?
I'm sending you another picture in Slack.
Okay.
That you can bring up.
There we go.
Yeah. So here we go. So this here is 16 ports, and you can clearly see which ones are bundled and which ones are quote unquote the hot standbys ready to take over. Now you can clearly see. Matter of fact, what I probably need to do is send y'all this here document that I made, this little homemade document that I made. But you can change the priority on the what we'll call the slave on the slave switch, and it will have no effect on it at all, which is basically what you see there. So I changed the priority to a lower priority to 20,000 on the wrong switch. You see, I got the master written on the one in the royal blue.
Right.
So what happens is that's not going to have an effect on the actual outcome. But like I said, I'm going to send y'all guys this here document, and I will drop this. Yeah, go ahead.
No, I want to ask you. So, and I guess I got to read more up on the port priority and all that stuff as far as for LACP. Whenever you change a priority for, like I'm looking at here, what I can assume here for individual link, is that the priority for the entire bundle?
No, just that link. So each link.
What does that do?
So basically, what happens is just like in spanning tree, where you can change a port priority, and let's say the switch will determine a root port based on priority of that port, if need be. The same thing here. Everything starts off at 32,768 as far as LACP port priority. Right. Now, if you change, like for example, you go over to the royal blue one. And matter of fact, I just sent.
Oh, there's another picture.
Yeah, I just sent the document up in was it the random room? Yeah, I just dropped it in the random room. I actually sent my little homemade document. Yeah. Okay. So this is what everybody's used to, right? This is the root bridge. Right. So we know that this here, what I call this dirty blue, is not the master, but it's the royal blue that's the master. Okay. Now, what happens is what I do is the next, based the way it's set up, the next switch that's in line, let's say in this case, it's Ether 541. If you look at the royal blue and the master, that's the one that's actually set up. If you go to the bottom, it's the first hot standby. You see at the bottom of that bundle bunch.
Right here. Okay.
Yeah, or even the next one. Yeah, on the master side. So in a good world, that 5/41 port would be the next one that falls in line to replace one of the other ones that went bad in the bundle.
Mhm.
Okay. Now, what I did was I actually went to test the theory. I actually went on the non-master and changed the port priority on the 3032 port. And you see I got a circle with the star next to it with a priority of 20,000. Okay. That port is actually linked to the 5042 on the master switch. That's why they both got those yellow stars next to each other, because they're both linked to one another.
Okay.
Okay, so if you scroll down a little bit more, what happens is I actually take one of those ports down. And if you look on the master switch in the royal blue, you see that the 42, the one with the star next to it, it did not change its status. But what it did was it went next in line and selected the 5041 port to go into the bundle. Because if you look at the top of that, you'll see that 5033 at the very top is down.
Okay.
Okay. That's because I wanted to make sure that if I change the priority on anything other than the master, that it would still hold true to what it's supposed to do. Right.
Okay.
So the master went to the very next one in line, which was port 41. Okay.
I got a question. So
Yeah.
they're all those ports, their LACP port priority are set to by default to the 32768.
Yeah.
And it's already stacked. Who's the next in line, right? Like
Yep.
Scroll back up, you see the hot standby was 5041, then 5042.
Right.
So if one goes down, and for example, 33 went down, the next in line would be 41.
Exactly.
But what you're saying is if you want 42 to go next in line, although it's second in line, you can change the LACP port priority.
Exactly.
You would do it on the master.
Right. So exactly what you're going to see here next is I actually wrote down there, I said port channels are normalized and we'll change the port priority back to the normal value. So scroll down a little bit more. Oh, Dave might have stepped away.
Yeah. Okay. So you'd want to do this. This is more so, well, when would you want to do, like, why would you, or when would you want to do? Because all interfaces, I would assume you want them to be the same speed, right?
You would want, they would need to be the same speed. Yep.
Right. So then why would I say, well, I wanted 42 to come up instead of 41 if they're all the same speed? Like, what's the...
Okay, so here we go here. So I normalize it and I say, okay, change the LACP port priority on the master with a decision to determine what the hot standby port to jump in to do the work in the event of an active failure. All right, so scroll down a little bit more.
Gotcha.
All right, now you'll see that I jumped over 41 and I gave a port priority value of 20,000 to port number 42. You see that there?
So that means for the next failure, that's going to be chosen.
Right. Just what Jermaine was explaining. Just what he was talking about, describing.
Okay.
So scroll down a little bit more.
That's it.
Is that the last one?
Yeah.
Okay.
Yeah, that's the last
one. So you see how the port 42 is now in the bundle situation, as opposed to go back up to the one before that. It probably was in hot standby. If you look at it in this one here.
Yep. Gotcha.
So the decision was made by changing the priority on the master, the LACP master switch, to determine which port in the bundle that I got free, that I had all these standbys on, which one do I really want to be next in line to take over in the event of an active failure of one of the previously bundled ports.
Okay.
Now, to Jermaine's question, when would we actually
What's the
need to
use
do
case?
this?
Right.
You know what?
Yeah, what's the use case?
I don't know. It was just something that I came across, and I was like going down that rabbit hole.
Okay.
I'm going
That's
down that
what
rabbit
I'm
hole.
thinking. They all should be the same.
I mean, that makes. I mean, I can think of a few. If we have, if we have a, aggregate layer switch with like 10 or 40 gig ports, and the 40 gig ports are all like are active bundles, but then, for some odd reason, the 40 gig port stopped working. We have some of those 10 gigs within that, ether channel. So then it's like, all right, this fails. This is where I put priority on the 10 gig for this first 10 gig port, and just, set an alarm to send a SNMP trap to our, server saying, all right, cool. This link is down, but it's back up, but it's running on a 10 gig. So go fix that. So,
because that's the problem there, because like Jermaine said, all the links got to be the same speed.
Okay.
You see what I'm saying? All of them got to be the same speed. So
that makes sense. Well, then that goes back to his question: when will we actually use?
Right. Yeah.
That failover.
Or is this just a config out there, like, hey, here's something extra out there for you guys, but do you really need it?
Do we really need it? And like I said, when I was going through my little Etherchannel, study session, I'm just reading all kinds of stuff and coming across all kinds of stuff. And that's where, Dave, you and I talked about this. The FLG version of the CCNP books.
Yeah.
See, the test guide books, the OCG don't talk about that too much. But the FLG start talking about stuff like, yo, I ain't never heard of this right here. What is this?
Dude, I got the email saying it arrived on my doorstep. I was like, hold on, I ain't ready to go in the matrix right now. You got to give me a second. Give me a second.
So that's the thing. When the ether channel goes down, the LACP master switch makes the decision on which link is going to be next in the standby situation to come active. And it doesn't have to be the root bridge. Because matter of fact, if you look at the beginning of that document, it actually gives you the command on how to determine which one is the master. Let's see here. What does it show? LACP.
Claude, you need me to show something?
No, it's show LACP sys-ID. That's the name of it. Yeah, hit your return key. And what it shows, what it shows is the 32.768 and the MAC address.
Gotcha.
And of course, what's going to happen is the 32.768 is going to be constant. So the tiebreaker in that situation is going to be the MAC address that determines who is the Yep.
So switch one is the master.
Yeah.
In this case for LACP.
Yep.
Yeah.
So if you wanted to decide what port to come up next out of hot standby, you'd want to configure this on switch one.
Exactly.
Okay, that makes sense.
Now you may not ever see that on the test, but then again, on your CCIE, I don't know what they're gonna throw at
you. Yeah, I'll take whatever I can get, because I haven't seen it. I got a straw. I mean, they gonna send me. They just yo, here's frame relay. What? Who uses that? So I'm gonna be over there looking at Jermaine. I'm like, bro, you all right? Frame relay over there. What you got going on over there? Oh, Dave, I got some hubs over here. What? Dude, Claude, this was good. I don't even feel like labbing no more, because I got to grasp just your breakdown of just that. This is enough for me, man.
Yeah. That little picture with the ones and zeros, like I said, that's going to pretty much that's going to be how you're going to determine which link that is going to travel across. And if you
Can
need,
you
like I
post
said,
that picture that you did on Paint for the
let me
XOR?
see. Yeah, I can. Yeah, I do
Okay,
that.
yeah,
Hold on
if
a
you
second.
can, I'll stop sharing because we can. Yeah, because we almost at an hour, so we can end it
Has
here.
it been
Don't
an
want to,
hour?
you know.
It damn sure is. Yeah.
You know, Claude. You know damn well you long-winded. You know damn well you. Claude done forgot it's the year 2099. He's like, damn, I know I was talking for that long. Claude, this was, like I told you, I read multiple documentation, like, and it's like, again, I know I make jokes about the big words, but sometimes it's just too much to the point that it overwhelms the reader. You just breaking it down just like this. I'm like, bro, I don't even need to lab this up. I can do this on paper. So, this is excellent. This is dope.
Let's see here.
This is dope. Man. Oh, Carlos, I didn't even see people were in here. Carlos, what's going on, man?
Everything's good, man.